In this tutorial video and the following one, we're going to make our robot have the ability to think at a very basic level, give it a little bit of logic, and to do this, we're going to introduce sensors. So our robot is equipped with three different types of sensors. It has two physical bumper sensors, so when it hits something, it's going to tell the robot to stop. It has a distance sensor, which is in the front, which uses infrared light to detect how long it takes for the light to bounce back and is able to calculate the distance based off of that time. It also has two eye sensors, which allows it to detect colors of our objects. So it has one on the front and then one on the bottom. So if we can use it to, if we pass over or see something of a certain color, we can make it do a certain sequence of codes. Okay. So for this tutorial video, we're going to introduce the distance sensor, and we're going to make it so that when the robot gets close to the wall, we'll tell it to stop. Okay. So first things first, we're going to tell the robot to drive forward, and then we'll make it run. So again, all we did is we tell it to drive forward. We're not making it think. And so because of that, the robot will continue to drive forward even when it crashes into the wall, and it'll do one or two things: either clip through the map and then fall out, or it'll tip itself over. Okay. So to fix this, we need to make the robot think for itself. And so with that, this is going to be the distance sensor. So we're going to go to our sensors. So we have our bumper, distance, and our eye. There's also a GPS sensor because it uses the map location. But again, that becomes a little bit more complex, which may be discussed later on in a different tutorial video. So here we have our distance sensors. We have two different types of blocks. So the first one says, did we find an object? And then the second one is the actual distance that it's reading from that sensor. So what we want to do is we want to tell the robot to keep doing whatever's in that sequence until it stops. So we want it to drive forward until we get too close to something. Once it gets close, then we'll tell the robot to stop. Okay. What I also want to do is the robot drives kind of slow, so we're going to make it speed up. So we're going to go to the drivetrain settings category, and then we're going to grab the block that says drive velocity. And by default, I guess it sets it at 50%. I'm going to change that to 100%. Now, pretty much we see this shape and matches this block right here. So I logically, we pretty much throw it in there. So then, the idea will be that we drive forward until the sensor picks something up, it sees something. And then once it does, it stops. So let's go ahead and run the code and see if that works. As you can see here, I ran the code, but the robot did not move at all. Okay. The reason that is that the sensor did pick something up. The issue is that the range of the distance sensor is about 3,000 millimeters. If we look at this table right here, this is what the distance of the closest object that it sees. In this case, it's 1839, which is the wall on the opposite side. So the map is roughly 2,000 millimeters by 2,000 millimeters, meaning that the distance sensor can see well beyond that map, which is our issue. So because of that, we can't really just use that. So instead, what we had to do is kind of like when we did the ignition system in Tinkercad with the circuits, that we use a dial to turn on an LED or off, or the potentiometer. We're going to do the same thing. So what we want to do is we're going to compare the value of our dial or our sensor, and then with whatever random number. And then once it triggers that, meets that condition, then we'll tell the robot to stop. So we're going to our logic, go to our operators, the green category. And again, we're comparing two different values. So that's going to be this second block here, 0 equals 50. So now I'm going to go ahead and add in front distance on the first one. And basically what it says that if that distance reads at 50 millimeters, we're going to tell it to stop. Otherwise, it's going to keep on driving forward. But instead, let's say if the distance is less than 50, we'll tell it to stop. So once it gets really, really close, it's going to make the robot stop. So I'm going to go ahead and run my code. So there's the robot driving, and then it got a little too close, so it's kind of crashed into the wall. So let's increase the distance and see what happens. So let's change that to 100. There we go. So here we can see that the robot stopped. The only issue here, if I look at my distance, it says 59 millimeters. Now, the reason that is because, again, it takes time for the robot to process information and also the how fast the robot's spinning, motors, physics and inertia and things like that. It does not stop instantly. So it takes a little bit of time for it to stop. So in this case, it gives it about takes about 41 millimeters to stop when it's running at 100% speed. Okay. But again, the idea is that we had the robot stop when it got too close to an object. Okay. So with that, that is pretty much how to use the distance sensor so that when we get to a certain distance, we tell it to stop.